Hi everyone. All right, my screen shared. Hi everyone. As mentioned before, I'm going to talk about some of the common mistakes that I have found in EF Core. Lots of pain that I have gone through it, looking at others' code and trying to figure out why is it slow, and kind of also address one of the issues that some people may have regarding EF Core, saying it's slow, we shouldn't use that. In fact, a lot of issues that I have found is basically just misunderstanding of how EF Core works, and with some of the tweaks, sometimes I got even up to 100 times performance improvement just to add a few things. So hopefully what we're going to see is some of the issues that you might have in your project. You can then fix them up a little bit and bang, you'll get a lot of performance back. Also better memory, and in the end, what is even more important, better stability to your application, because the application no longer needs to work as hard as it did before. All right, so a quick introduction for myself. I'm Jernej Kavka. You can just call me JK. I'm solution architect at SSW, an AI Microsoft MVP. You can follow me on all of these socials. I'm also organizing a couple of meetups like APAC AI, Global AI Podcast, the Full Stack Brisbane user group. And predominantly, I'm a .NET Core and EF Core developer. I'm also dabbling in the AI, but this is my main thing that I do every day. And I really like to perfect my art. And this is why I have focused quite a bit to figure out what are the actual best practices for EF Core. Now, why I like to use EF Core is one of the big reasons for it is basically you get a nice balance between features. You get good flexibility as well as performance. Anyone who looked at how EF Core have developed since the start of 1.0 all the way to EF Core 6, they can tell you it's not just that we're getting a lot of features with every single release. Every single release brings us also a lot of performance improvements, which ironically means that some of my slides might actually no longer be relevant in, say, EF Core 7. Maybe Microsoft will say, okay, too many people have issues with that one. Maybe we can solve the problem for them. So that's one really cool thing about EF Core. On top of it, you can switch between different databases. And in my opinion, it's really, really good for relational databases, not just because you have joins and they're pretty performant. You can also switch between different database engines. So you're not stuck with just one engine. Oh, and we can't forget about migrations, database scaffolding, and there's a lot of tooling around EF Core, which is why I really love EF Core. And if you have any issues and you're thinking about, hey, we might need to switch to something else because of performance issues or something like that, hopefully this is going to help you stay on track. All right, so one of the motivations of why I wanted to build this is basically a lot of issues that people complained about that I have seen say, hey, this is running slow, were very easily fixed. Another thing that I also found is that when I fixed those issues, the code actually looked much more simpler, much more straightforward, and people could read it more easily, which was ironic because we actually make it more performant, yet it's more maintainable and more readable than the original code. So sometimes optimizing your code isn't a bad thing. and sharing the best practices. And those best practices are going to be backed by benchmarks and tests, so you can actually not just see the numbers. Most of them you'll be able to just pull my GitHub and try to replicate that for yourself. And lastly, I had some scars regarding EF Core and what I've seen, and I hope that I'll never need to see them again. All right, so test methodology for this was I used at the beginning a benchmark tool called benchmark.net, mostly for consumption, memory consumption, especially at the beginning of those more horrendous queries, to just show you that, yes, actually it has a huge impact, especially when your database starts to grow. Then most of the tests are going to go onwards with Bombardier, which is kind of like a simple load testing tool. You can say, have 5 active connections, and for 60 minutes, try to make as many requests as possible. So we have a little bit more real performance information. We don't just get one hit and then see how the database and our application behaves. We actually are hitting the service a little bit for a minute to see whether the performance gets worse over time, or we have a stable performance. Then I also use Postman for that, and doing one-hit queries, and also most of the examples that I do return back the actual SQL statement that was executed, so that we can compare what is actually executed on SQL Server for each of the cases. And all of these samples are in .NET 5 and EF Core 5, because I started this demo about 3 months ago, 4 months ago. And I really wanted to show one of my clients, hey, these are the issues that we're having, and here are the better examples of how to do it. All right, and also this is my machine, in case you're interested what is the performance metric for my, what hardware am I using to do all of this performance test. The SQL Server is on my machine, as well as the application. So that might not be the best perfect testing machine for doing that. But I think what I have tested in production, it's a good enough indication to tell you which code is better than the other. All right, so for the test data, I have downloaded from this link. And this test data has some simple tables like customers, employees, products, and sales. The most important one is the sales, which have 7 million sales in it, just to drive home what can happen when you write a bad code and then the database starts to increase in size. Then all of a sudden, something that was okay in performance when you develop the application, when you push it to production, a few months later, suddenly the entire website doesn't work anymore. And I'll show a few pitfalls that I actually found in actual production that caused the entire website no longer working. All right, so one of the common mistakes that we'll look at today is going to be going from iQueryable to enumerable. I'll show you some of the pitfalls when you do this kind of casting. Then not using S-node tracking. You might know that EF Core, when you get data from the database, they're tracked. And with S-node tracking, you can make them not tracked. And we'll see the impact of that. Then getting all data when it's not needed sounds obvious, but in a lot of cases, obvious doesn't seem to be enough. Explicit joins, they are sometimes really good. When you do the queries, you do .include the additional tables, but they can backfire. And I can show you how you can avoid those issues. Then we're going to have pagination. That is also a very common issue that they have found with pagination just when implemented correctly. And lastly, over complex queries. I'm going to sprinkle a lot of wisdom all around the session, but these are the main points that we're going to go through. And when I first started doing EF Core, and when people say, look, you can quickly screw up with queries, I was thinking, how bad can it be? And for years, that kind of was in my back of my mind. But in the last 2-3 years, I really started to look into, okay, how bad can it be? And let me just say that sometimes some questions shouldn't have an answer. And, this might be one of those. And let's start with something very innocent, counting. You would say, well, yeah, we have here an example that is obviously horrible, right? We have naive count, we have here the table cells, then we do toList, and then count. I have seen this in production, but it's an easy fix. You just remove toList and it's done, right? But there is one less obvious one. So here we have again cells table, but we save it under a variable which is IEnumerable, and then we count. Now, conventional wisdom, considering how C# works, would be that this should be fine, right? Like, it's enumerable, so when you do .count, obviously it's going to execute on the database, right? Well, they are kind of the same thing. So when you run this as an enumerable, you are getting all of the data from the database. So this is one thing that was pretty interesting to find out. So yeah, when you cast to enumerable, from that point onward, everything is in memory. And there's also the problem of naive where, or anything that actually has a method like this over here, where you basically returning a table, but a table is not iQueryable, it's IEnumerable. And now you can start to think about, wait, we have used repository patterns and they are returning IEnumerable. And then you start to think, oh, all of the data we're trying to get from the repositories, we're getting all of the data from the database without filtering first, and then we're filtering in memory. And then you're starting to realize how many places you have performance issues. So what IEnumerable is one of the issues that I found to be the biggest performance and memory issues in most of the applications. And you should avoid them as much as possible. If you do repository pattern, maybe consider using iQueryable for the methods that you know that they're going to be filtered on a higher level. iQueryable is not linked to EF Core. So if you have a different database engine, you'll still be able to use iQueryable despite, making that, giving you the ability to actually change what is going to be queried in the database. So what's going on? So why is this a problem? Well, first, we download the entire database, obviously. But there's other issues as well. So because EF Core supports entity tracking, what happens is that all of these entities are being tracked. And in order to make them tracked, it consumes a little bit more CPU and it consumes a bit more memory. And then once we get all of that data, we're processing them in memory. We're doing the filtering, we're doing selecting, order by, and all of that stuff we're doing on the .NET application rather than on SQL Server. And if that's not issue enough, in the end of the day, we also need to run all of this data through garbage collector. So garbage collector now has to do a lot more work than it would be necessary if we wouldn't need to process everything in memory, if everything would be on SQL Server. And just to give you a feel for scale, so for instance, if we have 7 million rows and each of them have 5 integer, that on its own is already 140 megabytes of data you're downloading from SQL Server. That's already a lot on its own. And we're talking 5 integer. We're not talking about text and other things. And tracking also adds about 4 bytes per property per row, although I found that that metric might not be correct. I'll need to double check on it, but at least it seems to be 4 bytes per property per row as far as I understand it. So minimum consumption would be 218 megabytes per call. And now imagine you're trying to count all of the sales, and that takes 280 megabytes to count all of the rows. That's quite a lot. And also it's slow and uses a lot of CPU. Now, the simple solution here is very simple. You change from IEnumerable to IQueryable. And this actually prevents the query to be executed in memory and gets executed to SQL Server. And to go back to how bad can this be? Now, if you have a small database, it's probably going to be a difference in a couple of milliseconds. Here we have 7 million records. So yeah, we can see here naive count takes just about 3.6 seconds. And takes, I think this is about 2 gigabytes of RAM. Now, this is not a perfect test, especially for allocation, because what the .NET benchmark is doing is running the test multiple times, and I'm trying to create and dispose EF core, and some of the memory of the previous execution may bleed into the next test. So it may not be the perfect test, but you can see here that the difference between the one that we did with IQueryable versus IEnumerable, the difference in memory is massive. You cannot even compare this. This is like 100,000 times larger. And, you know, well, performance is great to have faster and faster execution, which here you can see that it's basically 63 times faster. I think the most important metric here is that you don't consume all of the RAM on your .NET application. And similar thing here for doing the where clause, enumerable versus IQueryable. Obviously, the performance is 100 times faster. As I promised you, we're going to look at things that makes 100 times faster, and changing from IEnumerable to IQueryable is one potential candidate to increase performance even in the scales of 100 times. And you can see here that allocation is also a massively smaller than what we had before. And, you know, to just drive the point here, I used Bombardier, and I'll show you example how I used it, to basically load balance this for a minute with 5 connection as much as it could. And the results that I got is that the naive count actually managed to do only 0.1 requests per second, and it totaled with 10 responses for 5 connections constantly pinging for 1 minute. So that is actually pretty terrible response time. Compared to that, when we have improved it with just changing enumerable to iQueryable, you can see that all of a sudden in 1 minute we got more than 1,000 requests back, and the request per second increased to almost 18 requests per second. So the increase is massive. All right, so let me, before I switch to this, let me show you in the code how this actually looks like. So over here, I have the worst case scenario. So over here, what I have done is I use iQueryable for this, but I could use IEnumerable. And for the result, I used toList. Don't mind tag with context for now. I can remove it just to not confuse anyone. I did toList and then count. So this is going to cause performance issue. And here the query to's query string, I use this. This is an extension method to EF core where you can convert a iQueryable into the actual SQL statement that it would execute. There's one caveat to this, is that you cannot do against count, first of default, max, and a couple of others where you actually need to execute the query. So this to query string is not going to you're not going to be able to do it against first of default and those kind of things. It's basically almost expecting it to be a list. So that's one issue with that, but it's good enough for our case. And what I have here is the application running. I'm going to restart it just for sake of argument. And what I'm going to do is, let's clean this up. Just to show you what I'm doing is I'm going to take the name of the controller, which is examples count slash, and this is worst case. And I'm going to bring up my task manager. So here we can see that we have 0%, 300 megabytes on Windows Terminal. So when I run this, you will see that CPU usage jumps significantly. The RAM usage jumps significantly. And this is now happily processing behind the scenes. So we wait for 10 more seconds, and we should get results. By the way, if you're interested about the Bombardier tool, let me get the browser over here. You can get it on the GitHub page, Bombardier, from Code-Sandberg /Bombardier. And it's a really good, a good tool for you to benchmark things a little bit more organically than, hit with the Postman and see what's the result. Now, this takes a little bit of time after it finished because it waits for all of the requests to finish. So you can see that it takes a long time to just finish off everything. Oh, now it went to 17 gigabytes. This is why you try to avoid IEnumerable or toList prematurely. Okay, this may take a while. Is it because... interesting. Why is Edge using that much? Okay, usually that took a little bit faster. Anyways, I'm trying to show the point, and I think I got my point here. Usually it finishes much sooner than this, but I'll kill this because it takes way longer than it usually does. And what I also okay, Windows terminal completely frozen. That's all right. I'll just kill that. All right, so here we can see 0. That's wrong. I have tested this right before doing this test. Anyway, so I'm going to run this, and I'm going to show you in Postman over here. There's a few things that I have done. When we run this, when I do one request, and by the way, you'll be able to get this all in the GitHub. When we run this, this is going to also respond with a specific request, with a specific answer. And what I'm doing is, when I'm getting a response, I'm actually using Postman to show the result in a little bit more stylized way with a visualizer. So hopefully, yes, we finally got a response for the worst case. Now, when I visualize, this is the query that's been executed on the SQL Server. Now, if we do the best case, which basically means just we're using iQueryable, we can see here that the query changes. So let's visualize this. So you can see that instead of doing the proper select statement, we just have select, count from sales, and then as, but that doesn't actually matter. So the major difference here is, if I scroll down a little bit further, is that I just do count and that's it. All right, let's go back to the slides. Hopefully that Bombardier is not going to cause too much problem, because I wanted to show some of the performance issues that I haven't put into the slide, but we'll see as we get to that. Now, another thing that you might want to consider is as-not tracking. Now, as-not tracking, what it does is it excludes tracking on the entities, and that results in using less memory, less CPU usage, and those entities are not tracked. Now, that means that you cannot update or delete unless you retrack them. Now, if you track them again manually, all of your properties might be marked as changed, and then if you do an update, it will update everything. So maybe not the best thing to do, so just use as-not tracking when you want to get read-only data. But the impact of doing that is pretty significant. Now, I don't usually see this much performance improvement. Here we have literally 5 times faster performance, and we even use up 4 times less memory than the than the initial code, which the only difference is that we added .as-not tracking. But what I have seen in practice is that you get at least 33% better performance, and you get at least 50% more less memory consumption. So if you can just have the data as read only, do use as-not tracking. It's a one-liner that can give you huge performance benefits. So here you can see that we have the same method without as-not tracking. We got about 100 requests per second. We did the same with just adding as-not tracking, and we ended up with 4 times better throughput than without it. So it's a very easy way to get better performance. Another issue, very common issue that I have found, is also using explicit includes. That means that you have .include and say we're getting the customer table. Now, one of the issues that I found with this is they usually put it into a method, They say, okay, this say the sales table includes all of the tables, because you just want to make sure that all of the tables that you might need are there. But that is a terrible thing, because even if you don't need that data, even if you do mapping and you don't use any of that data, it will generate a SQL statement that will include the all of the tables in your joins. So you have now an unnecessarily complicated query. And to solve this is, for instance, over here, we have a include over here, and we're getting all of the data for that salesperson. And then we are separately doing the mapping from the full sales table with the salesperson. Now, alternatively, you can actually do the mapping in the database, and as an added benefit, you can directly reference the salesperson, the first name, and that will result in a implicit join. That means that, as you can see here, I'm actually not using any includes. And if there's a spec change, that actually we don't need to have the salesperson first name or things like that, and we no longer depend on the salesperson. Once we delete them from this mapping, we suddenly have no joins in our SQL statement. So you don't have to constantly think about, am I using an include too often, which have pretty significant performance impact. You just have you can just forget about it. One note, however, for this one is, if you pack this as a method, you need to do it as an expression of a function. If you just do as a regular mapping thing, let me show you as an example. Say we go to the where clause, and let's just take this one here. Let's say that we do dot select x new this is sales. Yeah, so let's do sales model. And let's just say that what we're trying to do is we're trying to get quantity equal x quantity. We want to do sale ID x sale ID. And then we want to do product name x product name. It's going to be product dot product name. And let's just say that we are returning sales model, sales model. Let's just simplify this, and I'm just going to put over here. We don't need to complicate things. And just bear with me for a moment. So here we have a simple example of how we do the mapping. And what you can do is you can actually do Control RM, or you can do Control dot, and then extract it as method. And what you'll notice here, this is an expression. So this is going to be executed on your server. Now, if I do the similar thing, but instead of this, I'm going to do this. So I'm going to return the sale model. and this is going to be X. I already have an X. And I use map in memory. I use this instead. Just do this. This is now going to be processed in memory. So everything after this is actually going to be in memory. Sorry, not in memory. There's a different trick. In later EF core, actually, this is executed in the server side, but you will lose this mapping over here. So this is going to result in null. Because you can get only the actual sale table, sale entity, it will not know that you actually also want to have reference to the product table, and this mapping over here is going to fail. Whereas in this case, where we're returning back an expression, it will understand, oh, wait, you're referencing product. So I should also do an implicit join to this product. So this is one of the common mistakes that I have seen, and that resulted in ugly code that is absolutely not necessary. This looks pretty nice to me, and it's reusable, so you can use it in different queries, and also very performant because you only get the data you need. I've already done the demo. And also the performance impact. I kind of forgot to add the performance impact on this, but let's do this. We have here, did I forgot to add the MISC? Okay, I did forgot. But the performance impact here, oh no, I have here, sorry. So the worst case scenario here would be that we include everything. So if we go back to the example joins and we go for the worst case scenario. Worst case scenario is we're trying to get everything. And this everything results in, need to run the application first. Need to fix this first. Second, inverting everything. The joy of doing everything live. So I think I can just do that and .com. That was the original code. Now I should be able to run. So the impact of this is going to be that it's already running. Just make sure. Okay, it's just not putting it in the foreground. The impact of this is the worst case scenario is going to obviously take a long time to run. But if we look at the query, you can see that we have all of the inner joins that we have specified. But if we look at what we're actually using, we can see that we're only using the salesperson. We're not using the product, we're not using the customer, but we are still executing all of these queries. So right now it was 6.4 seconds. If you run this again, it's going to be slightly better, I think, because that was a cold boot. Yeah, 4.6, but it's a horrible performance. Now you can, it's not necessarily a bad case. I would discourage you from using this. You can add the include in the query, and that's going to improve the performance significantly. So that's only 2 seconds. But if I do this again, it's going to result in exactly the same problem as we had before. It's not going to improve performance, even though we're not using that table. Now, the time that you actually do want to use include is when you're updating the elements. So for instance, I want to get all of the sales for the salesperson. Say we get the list, and we do wait query dot to list, and then I actually want to update. Are you complaining? Does not contain definition. Interesting. That's a new one. List. Is it because I'm reusing it? I didn't have my morning coffee. Got to add async. So when you're in situation where you actually want to do this, and what you want to do is, for instance, you want to go, let's say, first one, and then you want to go to the salesperson and then update some of the information of that person, then in that particular case, you do want to do include, because all of that is going to be tracked. And when you do DB context dot save changes, that is going to be updated as well. So the included tables are also being tracked, and you can update them just fine. Now here it wouldn't update because we have as not tracking. So in that case, you would need to do with not tracking. And for instance, if I do change the name to be JK, that should work just fine. What are you complaining now? Is seeing method not accepting? Because I need to. Save changes async. Yeah, now it works. If I run this, even though this is a included table, it's going to update. So this is one case where you actually do want to have include. And just to show you the best case scenario, which is with the implicit join, if we run this, this is not only going to need to run this. It's not only going to give you a much more efficient SQL statement. So here we're not only efficient with the joins, we're also efficient for what we're asking for. And if you're interested at the end, I can show you that reducing the number of items you're getting from the database actually impacts the performance. So you can, this is kind of an almost double performance gain. And in my eyes, it's actually more clear what you're trying to do. Here you can see it's very clean. Here I note that this is only read-only data. We're filtering by that, and we want to have it in this shape. So in my opinion, that is actually a much more cleaner code. It's very concise, and as a bonus, it's high performance, and it has it's very memory efficient. So to me, this is a win in all regards. So usually what they tell you is don't do premature optimization. This would be the exception of this. There's almost no side effects of doing this. All right, so the next thing that there's a common issue that I found is the pagination. Usually it happens because what we're trying to do is filter data. We get the filter data, so we do to list, and then we count them already. And only after that, we apply tag, take, and skip. And some developers do that because they don't know they can use iQueryable to their advantage. So for instance, if we go to the pagination controller. The common mistakes that we have over here. So this is the worst case scenario. Here we have the query. We did the filter. Now, what I have seen, and this is a very common scenario, you wouldn't believe how many times this happens, is we get all of the data, which is not too horrible because we are filtering first. But what happens then is we're using that data to in-memory process additional things like skipping the page, taking a slice of the results and then mapping it, just so that at the end we can use dbResult.count, so that we can actually get the right number of results, so that we can then also show the right number of pages and stuff like that, which may look as a reasonable code, but a much better approach to this is leverage the iQueryable. Here we have the query. We do the same thing as before, but what we do is we make a separate request with this iQueryable to count everything. So what that means is we are telling the database that I want to have, I want to know all of the results based on this filter over here. And then what we do is we basically do the pagination. So we skip a couple of items, we take a couple of items, and then we make another request to the database to basically get that one slice of data that we're interested in. Now, this sounds like it should work worse because we're doing 2 requests into the database. But one interesting thing here is that it actually is the reverse. So if we do the worst case scenario, we can see over here we have a very simple request. We have one join, so that's not interesting. But what you may find is that this takes about 2 seconds to run. But if we do in the database, for instance, we end up having a bit more code. But so you can see here we have a bit more variables and stuff like that. But what you can see here, this takes only 127 milliseconds. This is on a completely different ballpark. So don't feel uncomfortable doing small calls to the database. They can actually be a significantly better way of getting data than trying to get a lot of data from the database and then process it in memory. And
so I'm just going to jump in a little bit. We're coming up on time, and honestly, I could leave you go for like the next however long you've got left, because like this is really interesting. A really good look at a bunch of stuff. So I guess my first question is, what's your next big tip for people that are wanting to learn about some of these common mistakes?
Yeah, so there's 2 big tips. One would be the thing with overcomplicated queries. And yeah, apologies for that. I was thinking that I don't have enough content, but I end up having too much.
We all have been in that space.
So one thing that, and this is all on GitHub, and I have done some performance benchmark and I'm going to improve them. But one thing that I learned is there is a thing where you can actually split queries into multiple ones. There's a feature called split queries. There's some caveats to it. Unfortunately, I don't have time to get into it. Where it allows you to split up the queries into smaller queries. For instance, salesperson, there might be only one, and it will query only one salesperson instead of duplicating multiple ones in the same row. That saves you a lot of transfer and also a lot of SQL Server process. But You can also do it manually, which I found to be almost 2 to 3 times faster than SQL Server. Than EF Core, but it's very simple. You just query the person ahead of time, and then query all of the data that you want for that person, and then just a simple for loop. You join those data together, and this is like 2-3 times faster if you struggle with performance in this particular case. Another thing that I want to
go. Okay, one last thing.
Yeah, cancelable queries. So this is very important. You may see that I'm doing in the request, I'm doing cancellation token, and I'm including those cancellation tokens in the to list, in the save changes, in first of default async. And the reason for this is, if you cancel your HTTP request, this cancellation token gets canceled, and if you don't listen to this cancellation token, what happens is the SQL Server will still go on. So if you have that count example where it took 6 seconds to process, this 6 seconds is still going to happen in SQL Server.
Yeah. Oh, that's a really good tip. I never thought to capture the cancellation token of the HTTP request and use and kind of pass that essentially as a kill code through to your underlying database calls as well. Just before we wrap up with you, I see that that's the slides. So the links to your demos. I did have someone ask a question that I also was wondering the answer to. The implicit include stuff, is that new to Entity Framework? Because I always remember
old.
Having to.
The problem with the implicit include is that most people use them incorrectly. So, for instance, they did the manual mapping, and they did the mapping, and they did the mapping, say, cell model map cell, right? So they did this, which is wrong, and this caused the implicit mapping to not work. If you struggle to figure out how to do this, just make the selection, do Control Dot, and basically introduce. Why don't you want to introduce the method? Anyways, usually it gives you the intelligence to introduce a method, and that is the right way of doing it.
Cool. Well, excellent. Thanks for that. Like I said, that was really, really excellent. And I loved how you stepped through all the demos and kind of broke each step down piece by piece, because I was able to really follow along how you kind of got to each step of the process and how you uncovered the different changes that happened along the way. But yes, unfortunately, we are just about out of time, and it's coming up to lunch, at least here in Sydney. I know that you're in Brisbane, and you're like, lunch, that's still at least an hour away. But I'm going to invite Lars back to the stream.